Alright guys, I'm just going to make this part one. It kind of ran long. It's about 20 minutes long of me just running my mouth. So this first video is just going to be me talking about the material choices. This will be part one of breech inserts for HW rifles. I'll finish back up with part two. Probably won't be near as long. I just got a little bit long-winded on this one, and anyway, it goes over material choices. I started out talking about breech inserts, but I kind of got off on other materials that hold up or don't hold up, or failures I've seen over the years, and why I've made the choices I have about what materials I use to make my components when I work on a rifle. Anyway, hope you find it informative. Hope you enjoy it. Thanks for watching. Alright, what we got here is a R10 barrel, and I'm hoping that the camera picks this up, but if you listen, you hear my fingernail pop over that little ridge right there on the side of a lot of break barrel guns, whether it be HW or any other manufacturer that uses little steel shims on the side of them. Sometimes they'll, a lot of this is somebody's had it over tightened, or it wasn't lubricated. They used the wrong kind of grease. This side here is not very bad, but this side's got a little bit of a lip in it. Years ago, you would even come in on some of these and they would be galled up real bad on the side where dirt would get in between the shim and mix in with the grease and just kind of eat into it, or it just got dry, and it over a long period of time it would wear in. It's a pretty good system that HW has, being able to adjust the barrel tension and address any issues that you might have with wear. Well, this is one of the areas that you can get a little bit of wear, so I wanted to I've got a couple. This is a used rifle that was traded in to me, and I'm going to do a little breech work on it, and I'm also adding this shroud to it. I just got it stuck on there for now, but I'm going to do a little video showing me doing the countersink on the sides of the breech, and the making the shims. I'll go ahead and talk about what material I choose, and why in particular I choose that material as opposed to something else. Over the years I've used several different things, and there's pros and cons, and then there's some stuff that's just it's a bad idea to use. Anyway, I'm going to talk about that a little bit anyway. So hope y'all enjoy. Okay, this is what I'm going to be using right here. I don't know how well the camera will focus on this, but this is what's called a aircraft countersink, and it's hollow through the center of it, and they do not come with the alignment pin or the pilot that goes into the end of it. You can buy different ones, but I make these out of 01 tool steel and heat treat it. This one I use on HW. It's just slightly, it's about 2/1000 under 7mm, which is a 7mm hole in the breech on HW gun. So once this is in the mail, once I dial everything on the X and Y axis, I can get it where whenever that drops in, I know I'm dead on. So when I make my shims for the side of it, and I make them also 2/1000 within 2/1000, they're also a good snug fit on the bolt. Everything will be absolutely perfectly aligned. I think on older guns I used to go 50/1000. On the newer guns I have to go about 35/1000. Sometimes you can get away with 40, but now that the barrels are threaded, you can get into a empty pocket where they've machined and threaded it, rather than the entire length of the barrel being pressed in like they were on the older rifles. Anyway, just wanted to give a little, kind of like a quick close-up so you can kind of get an idea of what that looks like. Okay, what I have here is I have 2 different grades of brass and 2 different grades of bronze and garden variety Delrin. I have in the past made shims out of the Delrin, and I used to use that exclusively because, you know, it doesn't there's no chance of it galling the metal. It's kind of a wear item, but Delrin doesn't really wear that much. It's a good load bearing material. It's self lubricating, and it's okay. It is plastic, and you know, every now and then I would have people, you know, say, oh, I don't want plastic, and yeah, I totally get that. This, you know, is made to be, you know, basically inexpensive and easy to replace, but I went to different materials because they do last, you know, they're going to last longer. You know, they're going to last the life of the gun is why I went to other materials. One thing that people get, or if people don't know, they're not a machinist and haven't dealt with a variety of materials. You can use words like brass and bronze, and they think, oh, it's brass, oh, it's bronze, and they don't understand that when you say bronze, well, there's, you know, I don't even know how many different varieties of bronze, and some of them are, you know, you can scratch with your fingernail, and, you know, if you hit it with a hammer or something like that, and it just crumbles. You immediately know it when you start machining on it. You know, I'm talking about oilite, which I don't have a piece of oilite here. What I do have is 660 bronze, and it's a pretty good material, but it's very similar to, like, this is 360 brass, and both of these, one of the big benefits to using these is they're free machining. If you you know, don't have particularly sharp tooling, or a lathe has a lot of wear, or it's just not a very rigid lathe to start with. And I started out when I first doing a lot of machining work on air rifles. I had an old Atlas lathe, and it had a lot of wear on it. Somebody had used it for grinding, and at that time I didn't really work on lathes or try and fix them or anything like that. But in this case, the bed had a lot of wear on it, and you know, I would lean more towards 360 and 660, 360 brass, 660 bronze, because they have a high lead content, and when you add lead to it, it's very free machining. You can get an absolutely beautiful finish on it with some really poorly ground tool bits. You can, if you got good bits, it's even better. But they're free machining, and a lot of people like to use stuff because it's free machining. The problem with it is if it's not a static application, but it's a dynamic application where it's where there's friction rubbing against it or something sliding against it. It wears a lot quicker than if you get something with a high tin or aluminum content. What we have here is this is 464 brass, and instead of being filled with lead, when you machine on this, it's a little harder. You got to have really sharp tooling or it doesn't want to cut. This is aluminum bronze, and this is 954. There's several different grades of aluminum and phosphor bronze that would work just fine in the application I use them in, but I always buy 954. It's the one, it's more commonly available, it's easier to get. It's one of the hardest bronzes they have, if not the. I don't know all the specs on some of the higher end bronzes, but this stuff is extremely hard. If you try and cut this with tooling that isn't just absolutely razor sharp, it just doesn't want to cut. Your bit just runs in and rubs against it. So you make something out of this, when you're done, you have something. you have something that's going to last a long time. And it's like, you know, at some point you quit making decisions. If you're producing something to go into service, it's like one of the things over the years and everything. It's like, yeah, there's a lot of stuff I could use, but I got away from lead content like 12L14, 12L14 steel, 360 brass, 660 bronze. Oilite is like pilot bushings for in automotive applications on manual, where the pilot shaft of the transmission goes into the engine. It was very common back then. It's a common bushing material. It was a lot of it was used, like in my hard engine. It was an older lathe, and it had pretty much, I think it was 840. You know, it's an oilite. It's an oil impregnated bronze, and it machines very easily, but it wears. It will wear out prematurely. If it's, you know, if in a perfect world and and you keep everything lubricated correctly, you never would have much of an issue. But in real life, you know, it's like changing oil on your car. It's like, how many people actually change their oil every 3,000 miles? How many people stay, you know, every time they go out to, before they drive their car, they're going to check and make sure the oil's up to the peak level. It's just in a real world, I'd rather have something that's going to hold up long term and never have an issue with it. And I'll go into that when I start making these inserts after I'm done on what. But I use 954, the bronze. It's extremely hard, very durable. You got to have good tooling to do it. 464. This is also commonly called naval brass, and I have used this, and it's a good hard product. It has tin as opposed to lead, like 360, and it's just really good stuff. I buy the bronze, and I keep it in a rack here. I buy it in bulk. I buy it by the pound instead of short sticks, and that's just what's worked for me over the years. Is, you know, get the best stuff I can get, buy it in bulk, because I do use a lot of it. So I keep this in stock. Now, if I remember correctly, it's like back in the 80s and the early 90s, I think Venom used to use hardened steel washers, and I've done that as well. I've, you know, 4140 or some tool steel or something like that, and then heat treat it. That's fine. I don't know that it's any better. Its hardness makes up for you know, lack of any lubricity, but you know, it's without getting into the whole thing about alloy cohesion and, you know, differences in hardness. The breeches on these guns are very soft, so a hardened washer would work fine, but it does require some lubrication, or it can get wonky on you. You could run this dry. No more tension that you're putting on the side of the breech. You could run 954 bronze dry and never have an issue. Another thing I've seen on, you know, back when the Air Arms Pro Elite was still being produced, the pivot bolt didn't actually pivot inside the breech. They had two washers that pressed in on the side of the breech, and those washers were centered, a centered material. It's you can Google it, look it up, but the centered material was extremely abrasive. Even when you lubricated it, if you tightened up the breech on those guns and you kept it snug, it wouldn't be long and the barrel would be flopping. And it's like, I used to have a lot of those rifles come in, and the forks would be, they would actually eat a groove into and a shallow pocket into the forks from the abrasion of the centered material. The centered material should have never been used in that kind of an application. A lot of those I had to make, you know, kind of clean up the forks as best I could, and then I would use the 954 bronze to make new ones to go in, and then you had to put it in and ream it all the way through and get it just exactly right. And they also had the pivot bolt was centered, the cocking shoe was centered, and the safety button was centered on the Pro Elites. And it's like, every single one of those items were prone to failure. The cocking shoes broke, the safety buttons would break off, the head would snap off the pivot bolt, and then the bushings on the side of the breech would eat into the forks real bad. None of it held up very well. That's just one of the, that's one of the things. It's like over the years working on this stuff, you see guns that, have rifles come through here that were built back in the 50s and 60s. And you can see, what it looks like if something's been shot several hundreds of thousands of times, and it's got a lot of wear on it. So centered materials, and you also got to take into account who actually manufactured the centered product. Some of them seem to be a little bit better than others. I've seen some from certain manufacturers that just did not hold up at all, was prone to fail. And then I've seen stuff from other manufacturers that have stood the test of time and looked really, really great. Unfortunately, getting into the, it's hard to say exactly when it was, but, it was in the late 90s. Everybody got on the centered material bandwagon, and everybody started producing it and using it for everything. It became very common in Webley for them to start using it for their trigger components. The Sears and the old, it was by the time they had switched over to the longbow, the tomahawk, and the later Webley Patriots. I just won't say Kodiak, it's the same gun, but all those had centered components in the triggers, and the sear edges would wear off really fast. I used to have the main sear that would hold the piston on Patriots. After about 2,000 or 3,000 rounds, it would wear down to the point that it could no longer hold the piston. You couldn't adjust the triggers because anywhere there was a sharp point where you were supposed to have a clean break on 2 contact points in the trigger, they would round off. And they would round off within 2,000 rounds. There's a toggle on the top of the longbow and the Patriots that were not the Patriots, the longbow and the tomahawk. There was a toggle, and the gun could diesel 2 or 3 times really bad, and it would just, the piston would rebound and hit the safety catch so hard that it would snap that piece in two. It's real thin, very small, but it was a centered product, and they were prone to fracture and break. I'll get off all that, but one of the things when you do this, as long as I've been doing it, you just start seeing what fails, what doesn't fail. You try a variety of materials. I've tried all kinds of stuff for different applications for this, that, and the other, and piston seals, bushings, trigger components, safety buttons. One common problem that people I see people, they get into making safety buttons, and first thing they do is they go out and get 360 brass. And I know there's several guys that work on rifles that will tell you up front, I will not put a brass safety button in your gun. They said they don't hold up. Well, that is because the people that made the safety buttons that they were putting in was made out of a very inexpensive lead-filled brass that was never meant in a dynamic application where that piece of brass is supposed to be rubbing against a piece of steel. They don't hold up, and they will fail in your gun, and it just fills everything up with that brass powder. If you need a brass safety button, you make it out of 464, which is a tin alloy brass, and it's much harder. It works really well. Bronze, the 954 bronze or even the phosphor bronze are really good for making safety buttons, but they do, especially the bronzes, they actually get a patina as they get old. Brass will turn green if you don't maintain it, you don't keep it wiped down and polished. The bronze will kind of turn a golden brown. And some people like that, some people don't. I think it kind of gives it a classic antique look. Of all the stuff that I use to make like trigger blades and safety buttons, I like using 954. And I like to, after it's got a little bit of age on it and everything, here's a blank I'm going to make a trigger blade out of. And it's still fairly shiny, but it's already getting, that patina on it. And it's got a bunch of oil on it, but you'll see that. But anyway, enough of me rambling on about materials. This whole video was going to be on me doing inserts in a breech. But I did want to touch into this. I do want to just wanted to touch base and say, this is what I'm using and it's why I'm using it. Also, anybody out there decides they're going to, a lot of guys out there, you got a lathe, you want to make yourself a safety button. If you want brass, don't use 360. If you're using bronze, don't use 660. You can kind of get away with 660 bronze, but it's not long term. It's not going to hold up. Get you a good 954 bronze. It's the hardest. It's what's gonna. It's not going to wear out prematurely. 464 or the common name is naval brass. 954 bronze is commonly called aluminum bronze, but even saying aluminum bronze, there's so many different grades of aluminum bronze, and there's a few of them that I've made gibs for arbor presses and stuff like that just didn't hold up. 954 does fine. It doesn't wear off. You don't get the golden smear from from something reciprocating back and forth across it. I've tried some other ones and I can't remember the grades right off the top of my head. But anyway, that's why I use what I use. I hope it helps somebody if you're going to make a safety button or you're going to make a component and you want it to hold up and be long term in your rifle. Anything your spring's setting against. Like rotation washers and stuff like that. Don't use 360. Don't use 660. Long term, it doesn't hold up. You can put it in there, shoot for a few hundred rounds, pull it out, and say, "Oh, it looks fine." But long term, the edges will flare over. You get a good sharp edge with a bevel on it, and I've just seen them beat out. It's just like using a soft steel and beating on it with a hammer. Eventually it will flare out. I've seen it flare out to the point that the piston wouldn't come all the way back and allow the rifle to cock and stuff like that. So if you're going to do a safety button or any kind of load bearing material, I would recommend 954 or 464 brass. 954 bronze or 464 brass. Avoid 360 brass. Avoid 660 bronze. Delrin does pretty well so long as you're not sticking in something with, a really large diameter wire spring. Most of the problems that people have using Delrin for bases and stuff like that usually gets broke on the installation. It's usually not a long term. Sometimes if there's a very thin flange on the end, it'll tend to, especially if you have a stem that's not perfectly true in a piston, repeatedly going down there, and because the stem's running at a different angle and the spring is pressing on that base. There's one guy used to make all his Delrin guides, and he'd have a little 100,000th flange on the end of it, and because the stem was running at an angle and the spring was pushing it flat, it was bending the guide over, and it would just, after a while, it would just snap off at the base. It's a very common problem back in the day. I've been seeing that since 93, 94. I mean, that's how long I've been seeing stuff like that. But anyway, I'll talk too much. I'm sorry. But anyway, I just wanted to reiterate and get the point across of what I'm talking about. The materials that I use. If you decide that you're going to make yourself a safety button or base for a guide or a top hat or something like that, try and use a quality material. just because, don't use something just because it's easy to machine and it looks good. I can take some 12L14 and I can make top hats. I can make bases for guides. I can make these shims to go on a side of a breech, and I could make it out of that material and it'd look absolutely beautiful, but it would fail. It would fail in short order. You know, you don't make material choices based on how good something will look after you get done making it. You want to make your decisions based on how it's going to hold up long term. Anyway, I hope this helps.